Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn trigonometric functions. Trigonometric functions are also called as circular functions. These are real valued functions which relate an angle of a right angular triangle to the ratio of lengths of two of its sides. These include sine function, cosine function, tangent function, cotangent function, secant function, and cosecant function. Now let us take a right angular triangle ABC, right angled at B. As we know, the longest side of right angular triangle is called hypotenuse. Here we take the acute angle A, then the side adjacent to the angle A is called base, and the side opposite to angle A is called perpendicular. Now we can write the trigonometric functions as sine theta is equal to perpendicular, that is opposite side, by hypotenuse, and cos theta is equal to adjacent side by hypotenuse. Tan theta is equal to opposite side by adjacent side. Similarly, we can write the reciprocals as reciprocal of cos theta is equal to secant theta, reciprocal of sine theta is equal to cosecant theta, and reciprocal of tangent theta is equal to cotangent theta. We can write tangent theta as sine theta divided by cos theta. Now, the oldest definition of trigonometric functions related to right angular triangles define them only for acute angles, that is, angles between 0 and 90 degree. For extending these definitions to functions whose domain is the whole set of real numbers, we involve the unit circle, which is an important tool to understand trigonometric functions. Unit circle is also considered as golden key to understand trigonometric functions. Now, a unit circle is a circle with radius equal to 1 unit. Now, let's take coordinate axes, x-axis and y-axis, and we draw a unit circle with center at origin. Now, this circle cuts the coordinate axes at A, B, C, and D. Here OA is equal to 1 unit, OB is also 1, OC is equal to 1, and OD is equal to 1 unit. Now let us take a point P on the circle. Then the distance OP is also equal to 1 unit, as it is the radius of the circle. Now draw a perpendicular PM on x-axis. Now we get a triangle OPM, right angled at M. Now let OP makes angle theta with the positive direction of x-axis. Then we can write sine theta is equal to perpendicular divided by hypotenuse, that is y divided by 1, and that is equal to y. And cos theta is equal to base divided by hypotenuse, that is x divided by 1, and that is equal to x. Thus we get sine theta is equal to y and cos theta is equal to x. Or we can say sine theta is equal to the y coordinate of your point and cos theta is equal to the x coordinate. Okay, now we use this unit circle to prove these trigonometric identities. For that, we take the unit circle, which we have already discussed, and in this unit circle, we take the right angular triangle OPM, right angled at M. Then by using Pythagoras theorem, we have x square plus y square is equal to 1 square, or x square plus y square is equal to 1. Since x is equal to cos theta and y is equal to sin theta, thus we can write cos square theta plus sin square theta is equal to 1. Okay, now we divide identity first on both sides by cos square theta, and we get sin square theta by cos square theta plus cos square theta by cos square theta equal to 1 by cos square theta. That is equal to tan square theta plus 1 equals secant square theta. Now again, dividing identity first by sin square theta, we get sin square theta by sin square theta plus cos square theta by sin square theta equal to 1 by sin square theta, that equal to 1 plus cos square theta equal to cosecant square theta. And these are our first three trigonometric identities. Now, since the coordinate axis divides the xy plane into four regions, and we call them as quadrants. Taking in anti-clockwise direction, we name them as first quadrant, second quadrant, third quadrant, and fourth quadrant. Now, in first quadrant, since both coordinates, x coordinate and y coordinate, are positive, that means cos theta and sin theta are both positive. That implies tan theta is also positive, as tan theta is equal to sin theta by cos theta. This further implies that all trigonometric ratios in quadrant first are positive. Now, if we move to quadrant second, in our quadrant second, x coordinate is negative and y coordinate is positive. That means cos theta is negative and sin theta is positive, which further implies that tan theta is also negative. Thus, in quadrant second, only sin theta and its reciprocal are positive. Now, in quadrant third, x coordinate and y coordinate are both negative, therefore their ratio is positive. This shows that tan theta is positive and its reciprocal is also positive. All other trigonometric ratios are negative in quadrant third. In quadrant fourth, cos theta is positive, as x coordinate is positive and y coordinate is negative. That implies sin theta is negative. Also tan theta is negative. Thus, in quadrant fourth, cos theta and its reciprocal is positive and all other trigonometric ratios are negative. Thus, in quadrant first, all trigonometric ratios are positive. In second, sine and its reciprocal are positive. In third, tangent and its reciprocal are positive. In fourth, cosine and its reciprocal are positive. In short, we can write A, S, T, C. For quadrant first, we can write A. For quadrant second, we can write S. For quadrant third, we can write T. And for quadrant fourth, we can write C. To remember this, we can use as add sugar to coffee, or all stations to central. A for all positive, S for sine and its reciprocal positive, T for tan and its reciprocal positive, C for cos and its reciprocal positive. Okay. Now we find how sine and cosine function changes in these four quadrants. In this right angular triangle, the base represents cosine function and the perpendicular represents sine function. As we move from 0 to 90 degree in quadrant first, the sine function increases and the cosine function decreases. Then, in second quadrant, the sine function again decreases, cosine function also decreases. In quadrant third, the sine function decreases and the cosine function increases as it moves towards positive direction. In fourth quadrant, the sine function increases as it moves towards positive direction and the cosine function also increases. Thanks for learning trigonometric functions. I will continue this in my next lecture. Till then, take care of yourself. Thank you.